Welcome to the We Hack Purple podcast, where each episode I meet someone who works in application security, who's fighting the good fight to secure all the things. I'm Tanya Jenka. I am your host, and this episode is sponsored by the Diana Initiative, an amazing conference that happens in August, right around when all of Hacker Summer Camp is happening, including Black Hat and DEF CON. It is a conference for people who are underrepresented in tech and want to find a place where everyone looks like them. This episode's guest is Anant. Anant, can you please tell the audience a little bit about yourself?
Hi, I'm Anant Srivastav. Um, Close to about 15 years of corporate experience, about 17 years. I've been a trainer, been involved with Linux for about 20 years or so. And I started out as a administrator, server administrator. Somewhere down the line, I did a lot of development work. And then around 2010 is when I fully moved into information security, have been into SOC kind of roles and then into pen testing kind of roles. To then in my last job, I was managing a team of about 50, 60 pen testers. To my current job or my current company, where I'm trying to build a small niche research based firm, which then gives out all the content, whatever we have researched, in the form of training programs.
So you and I chatted a bunch before we decided to record, and a thing that you and I were talking about is supply chain security. And I feel like literally every conference is talking about supply chain security, so we might as well do it too. um, can you explain for the audience, like, what does that mean?
Okay, so supply chain security is a very generic term which basically talks about whatever is the pipeline that is there to reach a product to you. Now, that's a general supply chain. Just like every other keyword that information security or information technology takes from other fields, they took this supply chain and they framed it in software context. So, what we generally in IT talk about is a software supply chain security. Effectively, when you are creating a software, so you're writing a bunch of code, what generally happens nowadays is you write about 20% of the code yourself, and 80% of the stuff is import this, import that, and then the whole thing works. At the code level, this is your supply. This is the chain that is there. These are smaller components that are basically forming your code. They are part of your supply chain. But the supply chain is not just this. There are bigger pieces around it. Right from, so if we look at it from a full end-to-end journey perspective, the code's journey starts from a developer's laptop where they have a bunch of different softwares installed. And then one of the software is an IDE, which has multiple plugins in it. And then that's where they're writing the code. From there, they are committing the code into a what you say, a source code repository. Mostly it is Git, but it could be SVN, it could be a bunch of other source control softwares. So the code goes there. From there, there might be automated tools like what we call as CI/CD or continuous integration, continuous deployment softwares. So those tools will basically take that code, perform certain number of actions on it, and then move to the next phase. Then you might have a test environment where the code gets deployed and you perform some test. Then there is a production environment where the code gets deployed and then other people can access it. The environments that are there are also pieces of this whole puzzle. To then the software that are used to monitor your production environment or your test environments,
Mhm.
every single piece that is there, right from every single software installed on your developer's machine to every single software installed on your servers, the entire pipeline is your software supply chain. A compromise at any of this level can lead to a compromise of your product. So that's the whole piece according to my understanding so far. What do you say, Tanya?
Oh, I agree. I saw a conference talk at B-Sides Ottawa in November of 2020 or 2022. And this friend of mine, Alex Dow from Mirai Security, he did a talk about how his pen testers attacked an entire DevOps tool chain. And, here's how we got in through Docker. Here's how we got in through Jenkins. Here's how we got in through this. And there was like 11 different points of compromise.
Yep.
And people said, well, why would someone attack your CI/CD? And then he's like, SolarWinds. Is that's what happened. If they could release your code themselves and have it go out into production to your customers, like, oh my gosh, that's so terrifying. It's like someone taking over your manufacturing factory for just an hour and shipping poison cookies.
So I have two stories around this. One is basically a news that is coming out now. So if you look at last few days, Circle CI got hacked, LastPass got hacked, or at least they accepted that they got hacked. Slack got hacked, Okta got hacked. These pieces, you won't actually consider them part of your supply chain, or in general, you won't talk about them because these are third-party SaaS vendors. But each of them are very crucial ingredients of your whole process. The second story that I had is, I think, from 2015 or 2016. We were doing a pen test and we realized that one of the website was exposing .svn directory.
Oh, wow.
So SVN was the version control system that they were using, and they were doing active deployments, and the .svn folder was exposed over the internet. So I've written a custom tool of my own. I was able to download the whole content from there. And the important thing that I got was the URL where the source code was and the username that was there, which was pushing the code in.
Was it root?
No, it was a proper username, but I did not have to even brute force the password. The same username was the password.
Okay.
And this company was a multinational company having all of their regional websites in those repositories. All we had to do was push one PHP file into all of them, and we had shells into 50 different regional servers in like a span of 10 minutes, because there was an automated deployment as soon as a change is pushed into the repository.
Oh, wow. Oh my gosh. You make such good points in it. I don't know if you remember, I think it was sometime last year where there was a company that had essentially an advanced persistent threat, which means hackers like living on your network for a while.
Yeah.
And the malicious actor, or like the ransomware group, basically started publishing to the internet pictures of the Slack conversation of the company security team, and that they didn't realize that their Slack had been compromised. And I remember trying to explain to some of my staff what out of band means. I'm like, we need to discuss out of band if something happens like this. And they're like, what's out of band? I'm like, well, for instance, not using our company email, like setting up a private, a Gmail account or something that we're all sharing, or just sending to our private emails, or using our personal cell phones instead of work cell phones. Like, you don't know the level of compromise. And they're just like, oh my gosh, working at a security company, Tanya, like,
So the important bit that I kept in mind was, don't store the data that you don't want to protect. That's the biggest key that is there. Unless you're an advertising based company where then you want everything stored.
Yeah, where you want to steal everyone's personal private information and sell it for profit. So if the entire supply chain includes basically everything that you use, including the ingredients to make your software, a thing that we briefly talked about was, where do you get your packages then?
Yep. So, this is a fun scenario because there's a concept of long-term stable releases, and I'm only focusing on Linux right now. We can kind of extrapolate it to Windows and Mac also. So there's a concept of long-term release or long-term supported releases in Linux environments. You have Red Hat providing their long-term release. You have Debian, which comes out like once in 3 years. You have Ubuntu, where every 2 years, their 0.04 release is actually a long-term stable release. The way they talk about stability is they will keep the packages in the same version. So no matter what software you're running, you are always sure that this version of software is present as the base product. This does not sit well with anyone who is a recent developer because they want to work on the latest version of softwares. So the problem that comes is you have Node.js, you have Ruby, you have Python. People are now installing softwares from different sources, which are not the distro maintained sources. So a distribution in Linux maintains their own packages, a small number of packages, and they try to maintain the security aspects around it. They try to tightly couple that, the updates should be there, they should be frequently pushed out, and all those things. Compared to that, if you have installed something from, say, pip or Ruby gem location, or let's say from a npm repository, the ounce of ensuring that the packages are kept up to date is on you. Now, this is where the fun part starts, because in all of these languages, the developer can freeze the version that they're using. Now, they're confident that the product works on this version. Let's say for one of the other reason, the developer is not able to update the versions or not able to test the software on latest versions, and a security patch has come up in the latest version. You can't install the latest version because you don't know if the software is going to continue working or not. I have, as part of my open source projects, I work on Android related distribution called Tamer platform. This was the biggest challenge that I had. One software needs Ruby, but a module of, say, version 5.4, the other would not work with 5.4, but would work with 5.3. There are packages which work with Java 11, the others will work with Java 17. So different softwares require different things. And because of those complexities, people end up creating a sort of a Frankenstein monster, which is a combination of multiple sources with no clear path on how the update should happen. Docker came up with the whole concept, or containers came up with the whole idea that, you package things in separate containers and then you isolate things. The problem that has also now happened is those containers themselves again needs an update process. You have isolated them, but they might still be vulnerable. And you again need to track one more thing. Where we are not able to track 10 things, now we have to track 20 things. So the cycle keeps going in. People keep looking at more variety. And this is where at times the thing comes that, hey, why not build something which is on a stable background rather than running for the most latest version of things? So the packages, so a long-winded answer to your question, the packages by default would come from your native sources. But the problem with that is they are not of the liking of what the people want to code. So the sources of packages are varied. Now, this is where I'll shift from Linux to, let's say, Mac. In Mac, any developer worth their salt would not be using the native development tools from Mac. They'll be using Brew, and then they'll be installing a number of packages from other sources. Brew then allows you to tap into different people's repositories and whatnot. The good part and the bad part about it is you are relying on someone else to ensure that the packages are updated. And then you are relying, and everyone else is relying on you to ensure that you keep yourself updated. If anyone fails in the chain, the whole situation is compromised. So that's the,
It feels
plus
like
and the
there's
minus.
a lot of trust going on.
Yes.
We shouldn't necessarily be putting our trust there. Like security people were big on not doing implied trust, where just by default we trust something. We're supposed to not trust by default or have zero trust, as the case is.
Yeah. I mean, it's an oxymoron kind of a situation for me. Security people talk about, hey, we should not be trusting other people. The one end of the spectrum is going self-hosting and just doing bare minimum and ensuring things work in your own environment. You have full control over everything. But when you
Mhm.
look at the recommendations given by most of the security professionals, they would be like, hey, someone else can actually take care of the security far better. So instead of you doing things in your own, you should be relying on a SaaS vendor to do things for you. Now you're dependent on that SaaS vendor. The
Mhm.
problem does not comes with having one or two vendors. The ground reality situation is right now all of us are dependent on maybe about 50 to 100 to 200 SaaS vendors, and every one of them have to keep their business functional so that we are secure. Now,
Yes.
so that is the other side, and the part about trusting. The bigger challenge that also comes. So let's say you are someone who does not trust people, and let's say uh, you are of the person who has done the full code audit of every single module that you've used. Now look at the situation that a decently sized organization, and let's say they're using Node as their language of choice. I'm just picking on Node because I hate JavaScript, but applies to every language.
Mhm.
So if they're using Node and they build a decent sized application, they might be depending somewhere between 200 to 500 modules.
Mhm.
Now, let's say you have a team of 10 people who are looking at your environment from a security standpoint.
Mhm.
Can you realistically believe that these 10 people would be able to audit all the 500 modules when a new version of them comes out and be able to provide a judgment to your team that, hey, the new version came out, it is good to be used? So
Yes.
if the ownership is taken at the org level, the complexities keep on increasing for them. It's a factor of manpower, it's a factor of cost and all of that, plus the rapid pace at which the development work happens. And the reason I keep picking on NPM, and I don't know if you've seen that, but there is an NPM module called is even, which tells you whether the number is an even number or an odd number. And then there is a
Okay.
module is odd.
Okay.
Both of them are developed by the same person. And I don't remember which one, but one of them actually depends on the other one. So it's like
Oh.
if you install is even, it depends on is odd. And what it does is it passes the number to is odd. And if the is odd says it's odd, it says it's not even. And if it says it's not odd, it says it's even.
Mhm.
So the dependency hell that is there with cascading dependencies. I mean, it's one side to talk about that, hey, I can just leverage a module and use it. But people keep forgetting a term which is called technical debt. Every time you use something which is not vetted by you, or you've not actually realized whether you actually need it or not, then a technical debt increases. The funniest situation comes not in the web application space, but in the mobile space. So you take an application, and let's say an Android application, you decompile it. And I've had this multiple times. You realize, okay, this application has 4 different packages which are doing root detection, which should be doing root detection. But at the end of it, the author has not called even one function out of those. They are imported for something else that is available in those packages. But this feature was there, but that was not called at all. So the code rot that keeps on increasing in your code base because of all the modules that you randomly just keep importing. And then a lot of times people don't even realize that, hey, I'm not using this module, or I found a better alternative. Remove this module. The whole aspect about reducing your dependencies on others where you don't actually need to depend is something people keep missing nowadays. Could be a factor of you need to build with speed, could be a factor of I don't care if everything works. All I need to do is add more RAM into the system, add more cores, and cloud supports me to do that auto scaling. And people don't care about it.
It's it's not ideal. I feel like when a lot of security folks talk about supply chain security, We just talk about a software composition analysis tool because
Yep,
it's something we can sell you. And
definitely.
and yeah, and I feel like you've outlined that there's software like the supply chain security, the idea of the whole thing is not just so software composition analysis tool or SCA. It's super helpful, does tons of stuff, but
Yeah,
also just teaching your developers to remove unused dependencies and to work with your technical debt to reduce it so you don't have so much security debt. And
yeah.
you can't sell that. So like a lot of companies are like, they can figure that out for themselves.
Yes. Because the number of hours that you spend on technical debt, there is no direct impact in terms of a new feature getting added. Although it makes things easier for you to work on a longer scale, but the immediate benefit is not there. So yeah, that is definitely there. There is one thing which, again, a reference I'll make. So a friend of mine, they run a company called Red Hunt Labs. They wrote an article about assets. What is an asset? So
Mm,
it was part marketing, part knowledge based article. But the
mm,
idea was to take the approach where asset does not necessarily means an IP address or a domain name. An asset for an organization is also the Git repositories that you have, is also the cloud accounts that you have, the S3 buckets that you have, and that random subdomain that was assigned to a developer to run a test environment for you. That's
yeah.
also your asset.
Yeah. Yeah, the test box that they forgot about from 2014
Yep.
that's still floating around there.
Yep.
Um,
So, yeah. So I was saying, besides SBOM, the other important, and this a point that everyone talks about, no one knows how deep the rabbit hole goes, is the asset inventory. You don't even know what you have, so you can't even protect what you don't know.
that is, it's so important. It's usually my first step when I get somewhere.
Yeah.
Um, do you have an inventory? And they're like, well, 4 years ago, we had a co-op student that interviewed some people and they made an Excel spreadsheet. And I was like, okay, so you don't have one. Got it.
Yep. So a fun story back from, I think, 2010, 2012 time frame. I was working with an organization and I was doing log monitoring and recording logs and analyzing them. And they had a massive project going on there where they were inventorying everything. So they had about 5,000 assets in their environment at that time. And we looked at the asset list and we're like, hey, there seems to be something wrong in this. And the thing that came up, and we were able to clean up that inventory to about 95, 96%, because we had visibility into multiple different logs.
Mhm.
And we used basic correlation techniques. If a Symantec AV is installed on your machine, there's a very high chance you are a Windows machine. If you're marked as a Linux box, I just need to double check once. Back in those days, Windows did not had 22 port open on them. So if there's a port 22 open on a device, there's a very high chance it is not Windows. So
Mhm.
we would use these correlation on like a weekly basis, and we were able to find so many discrepancies. Like a machine that is supposed to have Symantec AV installed because it's a Windows machine does not have Symantec AV installed because it is marked as a Linux box in the inventory. So inventory, when it was within the LAN network, we were able to do this because we had that kind of a visibility. But when you take the inventory out, like for example, the Circle CI hack, the credentials that were stored inside Circle CI, which were used to access buckets and whatnot across your network, you have no visibility of what is there, what is not there, and how you're dealing with it.
It makes me sad when tool makers get hacked because it's like, but I have so much faith in you. Now I feel like some of my faith is broken because I've used Circle CI. I like it.
Yeah,
I mean,
it's a good tool.
I haven't really met a CI/CD I don't like though. So
Uh, Have you played with Jenkins self-hosted on a limited amount of RAM?
No. I've only done the cloud Jenkins, so maybe, yeah. So one of the things we were talking about before was that you're more of an ops person than a dev person. And last year I wrote this article called like what is infrastructure versus what is considered like custom apps or software or stuff that
Right.
software developers work on. And I did it because I was talking with a friend who's kind of getting into tech, and he's like, wait, so operating systems are software, but it's called infrastructure? But when you make an app or you're one of those apps that you test, that's called software? He's like, isn't it all software? And so I wrote an article about it, and a lot of people read it. And I was surprised because I was like, this is so basic, no one will want it. So tell us, what does that mean, like being more into ops than dev?
Okay. So I'll take a slightly larger view.
Okay.
DevOps is the term that generally people use nowadays, but
Mhm.
the traditional format was there was a development team and there was an operations team. So if
Mhm.
you consider the older waterfall model, uh, a business people would, let's say your company is a software development or a software product company, there'd be business people would basically bring in the business or the idea that this is what we want to build. Then that requirement goes to the development team. The development team is supposed to do all the coding and get the software working as they feel that it should work. Then they would give it out to another team, which was called the QA team, quality assurance team. They would do all sorts of testing on it and tell you, hey, this is wrong, this might be problematic, this is where things are bad and whatnot. And then they would come up with their own recommendations. Development team will fix those and then it'll move forward. Just a side note, this QA team, the entirety of InfoSec under application sphere is kind of a part of this QA team. The same team we generally try to diss about. We are like a smaller portion of that QA process.
Yeah.
And then once the software is built, the development team would then say, hey, I've got this software working in my environment. We now need to make it available for our customer. So the difference is a software working for a developer means on my laptop, it's working. I can open a web page, I can see how the web application is working, or I can launch the software and it's working. But when you say, I want to make it available in production for all of our customers, that basically then means a separate set of processes where an environment is going to be created, which is optimized for your set of application role. And then tweaking would be done in the environment in such a way that the application can work like for all of your customers. Let's say if your customers are 10 or 20, I don't need to care much about it. I can just start the base software. Let's say it's a PHP application. I just need a web server, PHP on it, maybe a database server, and everything runs in a single box. But then let's say I have 50,000 customers. I'll be like, yep, this is not going to work this way. I need one server which is sitting in the front, then another server which is the PHP server, and then another server which is the database server. And then I need to optimize the database server so it can handle multiple connections because multiple people will be accessing things. I need to maybe set up a load balancer on the front so that if 50,000 people parallelly come in, they can be channelized and multiple servers can actually load balance everything. All this aspect of putting the whole software into an environment where it can function and serve a large number of people is what is the operations aspect. Now, what has happened is as everyone kept growing, there were differences between how developers would approach a thing versus how an ops person would approach a thing. Like, for example, I was talking about packages. That was a major disagreement between ops and devs. Devs would be like, I want to use the latest. Ops would be like, nah, you're getting this version of Linux, you're getting this package, figure it out. So then came a point where, in short, the developers were given the freedom that, hey, look at what the ops is doing. Can you do something about it? And the developers, being developers, they came up with an approach where, hey, why not try and figure out how we can bring the manual effort into automation, into code. So that's where the whole infrastructure as code piece came into picture. And the new term DevOps became common. Now, as security has it, my understanding, my usual crib about it, security wants a name of their own. So they want their own name in the picture. So it became DevSecOps, the term that should never have existed, but it exists. So Dev and Ops were two separate components which are now combined together. And the reason for combining them together is to ease out the whole disagreement between the two people, rather make it a single person's job. This is very much beneficial for startup space. It is very much not beneficial for a corporate space. On a bigger 20,000 people company, you don't want one person doing end-to-end work. You want 10 people doing checks and balances, doing cross-referencing with each other and getting the job done. But on a startup, you don't want to hire 10 people. You want one person do everything. If the person can mop the floors and bring you sales, you would be more than happy. So does that answers your question?
It does. It reminds me of a funny story. So sometimes companies will try to recruit me to come work for them. And I'm like, oh, I run We Hack Purple, so I'm pretty busy. And so the CEO is telling me, well, you really want to join our company because our product is made out of DevOps. And you like DevOps. And I was like, your product's made out of DevOps. And the CEO said, yeah, it's literally made out of DevOps. And I was like, DevOps isn't a substance. And the CEO insisted, no, it is. So you should meet our CTO, our Chief Technology Officer. So I met with the CTO and I said, oh, so your CEO was, and I, you know, like when you're friends with people that work at a company and they're just like, just go through the interview. And I was like, no, I'm pretty happy with what I'm doing. They're like, no, go. So I meet with the CTO and the CTO is like, oh no, our product isn't made out of DevOps. You're right. It's not a substance. And he's like, but we do DevOps. And I was like, oh, okay. What does DevOps mean to you? And he said, well, we can't afford two technical people, so I have to do the dev and I have to do the ops. So therefore, our product is DevOps. And I was like, I have to go now. I have to go. But at least he knew it wasn't a substance. So that's good. Okay, I want to ask you one more thing.
Yep.
Because I'll talk to you all day, just like I did last time we had a call. Okay, so Android security. So my Achilles heel of AppSec is mobile apps. And you've done a lot of Android security. Can you, I don't know, just tell us a little bit about that?
All right. So the major change that you have to do in your mentality when it comes to web apps versus mobile is that you have to take that whole idea out of your head that there is a trusted end. In web applications, we have the web server, which we can harden, which we can protect, and that becomes the trusted entity. And then what we can do is, hey, don't do anything client side, do everything server side, because server side, we know we can control. Yeah. When it comes to mobile, if your application is actually based on a client server architecture, you can rely on the server. But if you rely too much on the server, your application is just basically taking input, sending it out to the server, and then coming back, which means one, the slowness, two, the bandwidth consumption. It's not just that it's slow, it's costing money to the person to operate your app. Now, the other thing that comes is, one, the app developer cannot trust. So you can't rely on the server and you can't trust anything within the device itself. You don't know if the user that is running the application is a trustable user or is someone who is out there to hack your machine. You can't trust whether the app is running in a secure environment. You might be in a rooted device. You might be running in an environment where the idea is to cause damage to your product, or the idea is to not cause a harm to them in terms of not let their money be used in your application in terms of in-app purchases. So most of the mobile apps have in-app purchases. I remember the days around 2014, 2015 timeframe, before Pokemon became a big thing.
I
In-app
remember.
purchase hacks were the most common hacks that were there. So you would create an app, you would have the app with microtransactions built in. The person would basically install a software, and then all of your purchases would be automatically authorized without actually spending money. Funny enough, it was the gaming industry and especially Pokemon Go that kind of made it a hard thing for everyone. The whole root detections to SSL pinning to basically in-app blocking and the whole Apple and the Android ecosystem saying, hey, we need to do something about in-app hacks.
Yeah.
All of that came up somewhere around Pokemon Go and the other tooling that came up, other games that came up around that time. So in mobile security, one thing is you can't trust anything. You are running your application in a hostile environment all the time. So anything that comes cannot be trusted. You can't rely that a header that is coming from the server is a trusted header. It could have been faked in between. So every in and out has to be validated. You can't trust any of it. That's one major chunk. The other thing, which is where I have a gripe with the InfoSec community in general, what I'm seeing nowadays is there's a handful of people who are actually doing anything around the mobile apps themselves. What has happened is everyone has kind of figured out, hey, most of the apps have some web server sitting in the backend. So what we will do is we will not focus on the app itself because that's the tricky bit. We will start the app, start burp or zap, capture the traffic, and then focus on just the APIs. There are lots of problems that are there in the app itself, that are there in the device itself, that no one touches. Like, I think just 2-3 days back, someone posted a bug in Samsung's TTS tap to talk or push to talk service or text to speech service, where by just one intent call, you're able to get into a root shell, or not exactly a root shell, but a high privilege system shell, which then has higher privileges than what you have. Now, this is the other interesting aspect. In your web applications or in your server space or in your desktop space, you have the concept of a super user. You can become an administrator, you can become a root and then do a lot of things. Mobile devices are by default built in such a way that when you are the owner of the device, when you are running an application in the device, none of the applications or minimal number of applications are running with higher user privileges. You are running application as a very low level privilege user. A recommendation which a lot of times people have given on Windows that, hey, use a non-administrative user as your default user. Yes. So that's kind of the idea that mobile devices have taken, and they by default run in a non-super user or non-admin mode. That then means that one, if a user is able to find a way to become root, they'll be able to access a lot of things. For example, fun stuff. Google Authenticator, which stores your two-factor authentication. For a very long time, and I don't know the current state because I stopped using Google Authenticator at one point, Google Authenticator would rely on the fact that the application data cannot be read by other applications. So within Google Authenticator's app data space, there would be an SQLite file. If you are able to access that, it has the website or wherever you have accessed the token. It has the token value. It has the timestamp. All those details are there in clear text. They were not even encrypting that. And they had a very clear public issue around it. We rely on the Android's native capability to protect. If you're running on a rooted device, we can't do anything about it. So those sort of assumptions are there. Some people make the assumption on the side that, hey, it is protected. We will assume it's protected. The other people make the assumption, hey, everything is compromised, and they end up creating such a complex process where everything slows down. And they can't justify it, but that's how they are able to manage things. Like nowadays, everything is there. Your cryptocurrency wallets are there. Your banking applications are there. So in India, UPI is a big thing. So UPI is like a payment transfer. The whole gateway concept is there, and you can transfer money from one account to another across banks, across the country within seconds. So there are n number of apps which rely on that platform, and all of them are there in the device itself. And that's where the complexity comes, that the since you can't trust anything, you have to build checks and balances. The more checks and balances you build, the more complex the app gets.
It feels like a balancing act.
It is definitely. And then the next aspect that comes is people have now started relying on other frameworks. So again, the problem that, hey, native application is becoming very tricky for me. So, hey, can I use something which works on iOS and on Android? So there are now middle frameworks. So there's another layer of dependency now. So your application is built in the framework, which does the translation into native code, and then the native code runs. So these middleware again adds their own layer of complexity. So when we are dealing with mobile applications, let's say if I give an advice for a security researcher, the mobile application space is a bit more complex, but the understanding that everything is compromisable gives you the freedom to actually let your threat model fly out. And where we would stop that, hey, this thing went to the server, now I can't do anything about this server.
Yeah.
Here, you can control everything. Even if this data is going to the server, what is coming back from the server, you can temper with it. And if the app reacts badly, there is a problem. So that's for the researchers part. For the developers and for the for say from a developer's point of view, the more complexity you add into the application, the more difficult it is to protect it. And in short, like I said in the beginning, if you don't keep the data, you don't have to worry about it. So you need to keep revisiting in what you are doing. Do you really need to do that? And only do what you really need to do. You're anyways reducing your threat model.
That was such a good summary. Oh my gosh, this is awesome. Thank you. I feel like I could talk to you all day. I know I'm not allowed to. So you've done a bunch of really cool open source projects, and I was wondering if, like, just super briefly, if you could just tell us about, Code Village and Tamer Platform and Hacking Archives of India.
All right. So I'll take a very quick story-like journey.
Okay.
I started working with Android around 2010. I realized the software installation, because of all the complexities, and one is built in Java 6, one is in Java 8, whatever, was way too complex for people. So I ended up creating a very basic virtual machine which had the tools rightly configured. And I realized a bunch of people needed it. So I made it available publicly. That's when I started the Tamer project. And that has kept going on. So now we've reached a point where the new version is about to be released in a couple of months. And what we are doing with it is there is a virtual machine environment, there's a Debian package environment, there is a emulator that is available for Android devices. There is a package repository for that emulator, which will have like vulnerable applications or your hacking tools pre-baked in. And then there's a minimal tools sort of knowledge base, which will tell you what tool, how you can use which particular tool. So that's the Tamer platform. Because I wanted to do something for myself, I made it and made it available for everyone. The Code Vigilant project, yeah.
Oh, I just want to say, so for people that are listening, it's Tamer, like a lion tamer, TAMER platform.com. So go check that out. Yes, tell us about the next one.
So then I think around 2014, I was sort of in that zone where I knew how to write applications. I knew how to do the deployment and other bits. I knew how to pen test applications, but I was trying to figure out how to do code reviews. And I found another friend of mine who was in the same situation. And we were like, yeah, let's do something together. So that's where Code Vigilant started. And we took WordPress ecosystem as our base. So what we did was we were like, I am not going to find a bug if I start looking at a code line by line. So we downloaded, I think there were about 30,000 WordPress plugins at that point. We downloaded all of them. So we had 30,000 WordPress plugins, PHP code. And we were like, how does XSS happens? So the simple logic was echo, and if there's a $_get, that's an XSS. We wrote a regular expression for grep, ran that over the entire repository, and then manually analyzed all of them.
Whoa.
So we ended up finding about 300 odd bugs in 2014. That was the first iteration that happened. Right now, I'm running the second iteration of Code Vigilant. I stopped doing that because I was like, grep and then manually doing everything is way too complicated, way too problematic for me. And then the other things kept happening. So I shelved it. New things that happened in 2021, SemGrep came out.
Mm-hmm.
As soon as SemGrep came out, I was like, yeah, this sounds interesting. And the day they released PHP capabilities, PHP support into it, I was like, okay, take this, start writing rules, and start finding bugs. 2021, we ended up disclosing about 50, 60 odd SQL injections in WordPress plugins.
Wow.
All of that is on codevigilant.com. And right now, we're again running more code. So now what we're doing is, because we have a set process, so we run SemGrep and we find bugs. All of that gets piped into a vulnerability management system. That's where we do the trial and hit and validation of the bugs. And then we start reporting them. So that's a massive project that we keep on working.
Oh my gosh. Okay, so everyone go to codevigilant.com.
Code Vigilant.
So it's
Sorry.
CODEVIGILANT.com. Vigilant, not Villigent.
Yes.
Vigilant. Thank you. Sorry.
No worries. Okay. Then I think around 2015, 2016, I started going out of India and started attending various conferences. And this was a common thing that came up, that people were not even aware who is actually from India, but is actually representing people outside. Whenever I would talk with people from InfoSec space in India, they would be talking about people who are outside of the country, and they would be idolizing them, or they would be saying, hey, they're doing fantastic work. No one does things in India. I was like,
Yes,
yeah, that's not true. That's not true. There's so much stuff going on in India. So I started a hunt. So I was like, okay, I need to find out who are the good people in India, and there should be a place where people can see what these people have been doing. So if you now go to Hacking Archives of India, I think I've not updated 2021 and 2022 data in it, but till 2020, all the big conferences that used to happen, I basically went into all the listings and identified who all identify themselves as Indians, and I've then added their details in. So for each author, or rather the hacker, their name is there, their social media handles are there if they're making it available in public, and then all the talks they have done is listed. The fun part is the top person who is in that list, Somil, he has been active in InfoSec space since 1997.
Whoa. Whoa.
And a lot of people don't know. So this was my way of putting this out. So now whenever someone says, hey, do people in India do this? I'm like, yeah, go to that website. You see the whole list.
How can people not know? Like, India has such a huge technology industry. It's giant.
Yeah, it's giant. But the thing is, people don't glorify themselves. People don't keep bragging that we've done this, we've done that. At one side, I feel like that's a good thing. On the other side, I sometimes feel like, yeah, at least you should brag. At least you should tell people that, hey, this is what I am, this is what I do. So they're not doing it, I'm doing it for them. I'm
I
just
love
putting out
that.
this is what they're doing.
Do you feel like maybe that's cultural? Like,
It
I
could be.
lots of
It could be.
women are told like you should be modest, you should be humble. So then I tell them, oh, if you're going to speak at this conference, you should tell everyone on social media. And they're like, well, I
Yeah.
don't want to brag. I'm like, well, the conference wants lots of people to come. And like they have
Yep.
you speaking because they think people will really enjoy your talk. And and if you don't tell people, they can't come see it and they're missing
Yes.
out. And it's your fault. You're not bragging, you're informing them. I'm going to speak at this conference. I'm super excited to be there. I'm going to talk about XYZ. Come on out.
Yeah. I mean, for myself personally, it has been a bigger hurdle that I have to cross myself. I have
Mhm.
been more of in that jinxed. I would not jinx it by saying I'm going there and I'm excited. So I would end up not talking about it. And then most of the time, so this has been my kind of the way I would have operated. I would talk about whatever I've done, not what I'm about to do. So that's where it's a mental block that I'm trying to slowly come out of. But yeah, that's the thing. If you're doing something publicly, you need to at least talk about it, if not brag about it.
Yes. Well, then, on that note, I was going to ask if there's anything that you want. So, people who are listening, obviously, you want more Anant. This is clearly not enough. So, tell them where they can see you again or learn more about you or follow you.
All right. So I am available on all social media platforms under the name Anant Shri. So that's ANANTSHRI. It's kind of a combination of my first name and a bit of my surname. And I am also available on Fediverse, which is the whole Mastodon and the whole other softwares, via my email ID, which is anant@anantshri.info. And that's the email address, that's my Fediverse ID, that's my XMPP ID. So however you want to connect, talk, I am more than happy. I am interested in talking with people who are planning to do something interesting, who are facing challenges right now in security and just want a ear to listen to and maybe get some discussion going on. I won't say I'll be able to guide them. I won't say I'll be able to mentor them. But yeah, I can definitely be a listening ear, be a support system, and maybe give my thoughts about how things would work if I want to do it.
He also gives security training, folks, in case you wanted to know.
Yeah.
Oh my gosh, this has been so great. Thank you, Anant. You're awesome. I'm so glad you said yes. Thank you. Thank you for coming on the show. Do you have any last words of advice that you want to offer before I do the whirlwind wrap up?
Okay. I think two things that I keep on saying. One, don't idolize people. Everyone is doing their own journey. Don't idolize anyone. You do your own journey and you be a parallel partner to others. Help them, get help from them. The other thing is, it is okay to say you don't know. What is not okay is after 6 months, still saying you don't know. So say don't know, but then go and read, go and study, figure out what you don't know, and then you know that.
That is awesome. Thank you so much, Anant. Thank you so much to our sponsor, the Diana Initiative, which is a conference that is in Vegas this summer in August, right before DEF CON starts. Also, I have a small announcement. I have two things that I'm going to be doing. I'm going to be one of the keynotes at OWASP Global AppSec in Dublin, Ireland next month. And I'm going to be at RSA in San Francisco in April. I'm going to be giving a learning lab workshop about how to put SAST into your CI/CD pipeline without losing all your friends. And I'm going to use SemGrep, just like you were talking about. And it's like, how can you do this, but like not have it run for 400 years and tick off all of our nice newly made dev friends? So I'm Tanya Jenka. This was the We Hack Purple podcast, and we had Anant on, and it was awesome. Thank you so much for being on the show, Anant.
Thanks a lot for inviting me.
Bye, everyone. Thank you.
Bye, everyone.